The last example, example number 4. Barakah Bakeries claim that packs of 10 of their buns contain on average 75 raisins. A Poisson distribution is used to model the number of raisins in a randomly selected bun. Find the probability that a randomly selected bun contains more than 8 raisins. So you are having Poisson distribution, average of 75 raisin for 10 buns. Random variable x will be number of raisins, and x is following Poisson distribution with mean 75 for 10 buns. And then the question asks a randomly selected bun, meaning that question asks for one bun only. So lambda will be 75 divided by 10, which is 7.5. And question asks more than 8 raisins. So in that particular bun, you have probability more than 8 raisin. X is more than 8. Then just refer to the Poisson table, convert to the at least symbol. X is more or equivalent to 9. Then you have the answer 0.3380. Okay, for part B, find the probability that in a pack of 10 buns, at least 2 buns contain more than 8 raisin. So this particular question, you have in a pack of 10 buns, out of 10, at least 2 contain more than 8 raisin. So you have the new random variable here. Let's say we did not ask y. Y is the number of buns contain more than 8 raisin. Because this is what the question wants, more than 8 raisin. Out of 10, at least 2. So y follows binomial distribution because you have how many buns total, which is 10. And then you have the probability of success event, which is in one bun, that bun contains more than 8 raisin, which is your answer from part A just now. So answer from part A will be your success event for part B. This is another type of the question, meaning that the question being modified in order for you to use binomial distribution. And what is the symbol? At least 2 buns. So probability of y more or equivalent to 2. Can you use binomial table? Cannot, because you doesn't have this p in your binomial table. So the only method is by using formula. So by using formula, when you want to find at least 2, you have to count 2, 3, 4, 5 up until 10, which is too many. So use the complement event. 1 minus py is equivalent to 0 and also 1. So just add on these two probability. So you have to substitute into the binomial formula 2 times. The first one when your y is 0. The second one is when your y is 1. Using the p 0.3380. Then your answer will be 0.9013. Okay, the last question. Using a suitable approximation, find the probability that in a pack of 10 buns, there are more than 80 raisin. So this one back to the original random variable, which is x is number of raisin. And then x is following Poisson, with the lambda is 75 for 10 buns. Question asks you to use suitable approximation. So from Poisson, you have only one approximation, which is normal. So check the condition. Is it lambda more than 30? Yes. Your lambda is 75 here. So you can use normal approximation method. So from Poisson to normal, the parameter for normal that you must have is mean and also variance. Remember, the mean is lambda, variance also equivalent to lambda. So both are 75 here. Then follow the method of normal distribution. More than 80 raisin, so you have probability of x more than 80. First step is continuity correction. What is the starting number? More than 80 will be 80.5. And then second step, convert to the standard normal. X minus mu 75 over standard deviation is square root of 75. Then you have the z value more than 0.64. So this is the shaded area. You can have the direct answer from the z table, which is 0.2611.